Excellent. It's great to see so many people here on a Monday evening, um, which is really good. So thank you so much for joining us this evening. So let me first of all just welcome you to the Graduate School of Business and Law's Thought Leadership Program. The basis of this program is, or the reason for this program is to bring back alumni back home, back into RMIT, back into the graduate school, to reacquaint, to network, and to also to get information on important topics that will impact on your business and even on your personal life. So welcome back to the graduate school. Welcome to the Thought Leadership Program. We've got a really good program for you tonight. We've got some fantastic guest speakers. And our topic is data, big data and analytics, and the implications that has for Australian business. But before I do that, let me acknowledge the Wurundjeri people of the Kulin Nation, whose who are custodians of the land in which tonight's presentations will take place. And I'd just like to show my respect for their for the elders, both past, present, and emerging elders. And I always think it's also really important to remember that the Aboriginal people of Australia are the oldest living culture in the world at over 5,000 years. And I always think that if we were to emulate some of the things that is at the heart of their culture, like the love of land and respect for environment, that maybe we would have a chance as a civilization for a couple of more 100 years. So let's get started. So what I'd like to do is set a couple of ground rules for tonight. What we're going to do is we'll have both of our guest speakers speak independently first. We won't take any questions at the beginning. And then what we'll do is we'll have both speakers return to the podium up here, and then we'll have questions and answers for about a half an hour or so. And then we'll be networking again at the end of that. Just as a little bit of housekeeping, there are some toilets up here if that's necessary. You're more than welcome to get up and go get a drink. It is pretty warm in here at any time that you like. Let's get started then. So what I'd like to do is introduce our first speaker, who's Matt Kuperholz, who's the Chief Data Scientist and partner at PricewaterhouseCoopers. So Matt, he uses big data to help companies find value or find insight within their business to leverage their assets so that they can create value for their stakeholders. So Matt is also a really interesting character just to talk to and get to know. I haven't known him for that long, but he's a really interesting person. He was when I visited his office, he was explaining how the algorithm in the elevator that was taking us up and down worked. And I was wondering, look, we're going down, Matt. Why is this elevator going up? And he explained to me that the algorithm is operating efficiently. And Matt drove his motorbike here this afternoon, straight from the Docklands at more than 100 miles per hour, I would imagine, to get here on time. And so let me welcome Matt. Thank you for being here tonight, Matt. What I've asked Matt to do, first of all, is to give us kind of like a big picture of big data, where we're at, where are we going, what are kind of the implications, what do we need to look out for. Our second speaker is Associate Professor Shane Culpepper. So Shane, he's also a really interesting character. He's the Vice Chancellor's Principal Research Fellow in the Center for Information Discovery and Data Analytics here at RMIT. And getting to know Shane a little bit better, we've got common background. We both come from North America, and we both just absolutely love Australia and Melbourne, except at hay fever season. So what's going to happen is Shane, he's going to focus a little bit more on the implications of big data and how that's what we need to watch out for and where things are going to go and what needs to be done. So we've got two two very well-known and professional experts in the field of data analytics. So it's my great pleasure to kick off by asking Matt if you could come up and give us the big picture of big data.
You can tell I'm a computer nerd from how I spell my name. In 1965, when Gordon Moore, one of the founders of Intel, off only 4 data points, observed that the number of transistors or logic gates he was able to place onto a silicon chip using a photolithographic process was doubling roughly every 12 months. This was coined Moore's Law, and we know that if something doubles, it's exhibiting exponential growth. And Gordon Moore rescinded his own law 2 times in his career because humans do exponential really, really badly. And we do exponential really, really badly because there's not many things in nature that just keep doubling. It seems flat for so long, and then it hits this dog leg and just goes out of sight. And there's a great example that I've borrowed to prove how badly we do exponential, which is imagine a big pond with a single lily in the middle on day 1. And on day 30, at the end of the month, the pond's going to be full of lilies. And every day it doubles. 1, 2, 4, 8, 16, 32, 64, 128, 256, 512, 1,024, 2,048, 4,096, and so on. And you ask, what day is the pond half full? The pond is half full on day 29, 1 day before the end. And if you look at it 90% of the way through the time period on day 27, it looks like it's never going to be full. There's just this little patch of lilies in the middle and everything else is empty. But then it goes double, 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 and it's full. And that's the nature of exponential growth. But in actual fact, the number of processors on a chip has doubled roughly every 18 months since 1965, so for over 50 years. And there's a couple of ways that people like to drive that statistic home. One of them is your mobile phone has more computing power than the whole of the Clinton administration had at its disposal. The one I prefer is that the greeting card you buy at the newsagent downstairs for $1.50 that plays Happy Birthday has more computing power than the whole world had in 1950. Such is the nature of exponential growth when it comes to computing power. But if we consider the metric performance per dollar, then you start to see exponential growth in performance per dollar everywhere. It's really, really exciting. Batteries. Solar. It's not that solar cells are getting exponentially more efficient. It's that on performance per dollar basis, they're exhibiting exponential growth. We see it with communication speeds. We see it with storage. Hard storage, soft storage. We see it with all kinds of aspects of networking. We see it with the number of pixels on our charge coupled devices on our camera. And it's this exponential growth, and in fact the collision of these exponential technologies, that is so quickly changing the world that we're operating in for business today. And data's only one of them. And in fact, I abhor the term big data. I think it was invented by a bunch of vendors. Data is exponential. The amount of data being collected is growing exponentially. The velocity with which it turns up, the variety of data which we can process is all growing exponentially. And the vendors will have you believe that big data is something new and something we need to suddenly pay different attention to, but it's just actually data has been on this exponential curve. So I'm going to talk about the collision of 5 exponential technologies and what that means for business. And 4 of them we're very familiar with, and the 5th one is quite new. So my speciality over the last 20 years has been the application of artificial intelligence to real-world business problems. Now, the challenge with talking to you about artificial intelligence is you have to start by deciding what it means to be intelligent, let alone artificially intelligent. So it's a very challenging thing to define artificial intelligence. But for now, let's just say it's a field of non-linear, non-parameterized regressions. In other words, it can find patterns in very large amounts of data. And it's an exponential technology. It's mostly an exponential technology because it's been reinforced by the amount of data which is being collected. So when you've got these algorithms that have basically been around since the 60s, but you can suddenly present them with more and more data, and your computing power, performance per dollar is growing exponentially, you start to conquer things like computer vision with new algorithms like you only look once, or you start to conquer things like very complex gaming or very narrow AI with the amount of data. And then you get to reinforcement learning with AI, which is how AlphaGo, and if you haven't looked that movie up on Netflix, I'd highly recommend it, how AlphaGo beat Lee Sedol 20 years earlier than we thought a computer would ever beat a Go master. The third exponential technology, robotic process automation, also has been around for a long, long time. It's just computer programs. It's computer scripts. The robots are taking the jobs of the humans, the same way the knitting loom was going to take the jobs of all textile masters, or the Gutenberg press was going to take the jobs of all scribes. Robots are not taking the jobs of all humans. They're changing the shape of the workforce for sure. But it's nothing new. We've had macros for whoever knows how long, and we've had automated computer scripts for as long as we've had computer programming. But robotic process automation is certainly an exponential technology. And when it's combined with artificial intelligence, you're getting intelligent automation. Computers that are doing things automatically at a much faster speed and able to do it in the presence of large amounts of data, which is now able to be worked with in an unstructured sense. So in other words, things like computer vision or voice stress analysis or video analysis in real time. So you see, the interesting thing about exponential technologies is not looking at any one of them in a silo, but looking at the effect of all of them working together. The third one, the Internet of Things, the machine-to-machine web, Web 3.0, whatever you want to call it, basically is a combination of exponential technologies, communication speeds, battery power, processing, which allows many, many more connected devices to function together to collect more big data to be processed with artificial intelligence to then do automatic things. You see how these are all starting to reinforce each other to change the world that we're living in. And finally, what I spent most of the last 18 months trying to change the world with is, this shouldn't say blockchain, it should say distributed ledger, a new exponential technology. And I'll just spend a minute on it because after this we're going to talk about Amara's law. Roy Amara was an economist who observed that, a futurist, that we tend to overestimate the near-term effects of a technology and underestimate the long-term effects. In other words, there's invariably a period of hype where we think everything's going to change, and then we enter this trough of disillusionment. But then as time passes, we end up in a place where we never even imagined we'd be. Now, the thing about AI is that hype cycle was in the 1960s, and the trough of disillusionment was the 70s and 80s, when the government pulled out large amounts of funding when they realised that artificial neural networks weren't going to be the solution to every problem known to man. And now we find ourselves surpassing, through AI, our wildest dreams back in the 60s. Blockchain's in the start of this hype cycle, but it is going to, I believe, surpass all of our wildest dreams. And why is it so important? Well, when the internet was invented in the mid-70s, because the Americans were paranoid that the Russians in the height of the Cold War could bomb the centre of a network and take out the ability for all the spokes to communicate, they asked one of their research agencies to create a networking protocol that was decentralised. Take out any part of the network and messages can still get from A to B, and that's the internet. And what a great future-proof invention, albeit it's been patched to buggery, but it's still fundamentally that idea of a decentralised network that we're now watching movies on or ordering Ubers on or ordering food or all the things that we do with the internet were never envisaged when they invented it. All the things we're going to do with blockchain, especially when reinforced with AI, big data, robotic process automation and the Internet of Things, is going to be wildly beyond our meagre imaginings at the moment. What is blockchain about? Well, in this distributed network of the internet, if I email you a photograph, you don't say, "That's a great photograph, Matt. Let me know when you want it back," because clearly you want to enjoy it as well and you've sent it to me and you're going to want it back one day. You know intrinsically that I've sent you a copy because the internet's built for copying. So the challenge is, what if I want to send you something of value? Well, in real life, if I give you $10, it leaves my hand and enters your hand, and there's no question. What if I email you $10? How do you know that I haven't rushed out and spent my copy before you can spend yours? It's what cryptographers call the double spend problem. So what distributed ledgers have solved for is the ability, and before distributed ledger technology was invented or discovered, and I don't even want to start that philosophical discussion about which one of those two things it actually is, you had to move to a trusted central authority like a bank and say, "Please, bank, send my friend $10." And we both trusted the bank. Blockchain does away with that. We don't need a trusted central authority who is benefiting unreasonably from the information asymmetry. We can have a network of trust where I can give you $10 and you know that I still don't have a copy, and I know that it was $10, not $11, and you know that it was $10, not $9, and this doesn't need a central authority. So it's a layer of trust that has been missing from the internet. Now, I put all 5 of these technologies together to try and solve a very real problem, much realer in China than it is here, which is the problem of counterfeit goods. And we were solving, especially with food and ingestibles, for Fonterra, milk producer, and for Blackmores, a vitamins producer, with Australia Post and New Zealand Post logistics companies, and the ultimate client, Alibaba. How do we use blockchain and the Internet of Things and sensors to automate, through robotic process automation, the collection and instigation of data, which we process with AI, to decide whether something can be put in your kid's mouth or not? And with 300,000 kids made sick in China from the melamine milk scandal, this is a very real problem. So these technologies playing together are absolutely going to be able to change the world in terms of trust. And trust is fundamentally broken. And trust is fundamentally broken because these technologies have allowed our networks to become much more connected and diverse. So all of this is interesting. It certainly leads us to times of abundance. As Matthew Bishop said, this guy is the economist. The pace of change will never be as slow as it is today. And that's a beautiful way of describing the incredible abundance we're going to move into, not just as business people, but as a society. Now, abundance isn't good or bad. Abundance is just abundance. These technologies are great democratization devices. They allow... You don't have to be a large corporation or a government now to tap into machine learning algorithms that are open source and near unlimited computing power to solve what I believe, and I'm a glass half full kind of guy, the big problems facing us, not just counterfeit, pollution, disease, world hunger, education. But this abundance can also lead to weaponization of AI. And some evils falling into the wrong hands, which is why the initiative I'm now focused on is called Responsible and Trusted AI. Who verifies that the machine is doing the right thing? We're going to need new rules. We're going to need new environments and ways of doing this. However, what hasn't changed is the fact that data is an incredibly unique asset. Whether it's big data or little data or exponential data, it's just data. And it's an incredible asset. Why is it such an incredible asset? Because you don't use it up. If I get value from data through analytics, that data still sits there for someone else to get value from. If I'm a telco and I send out bills, then my billing data allows me to get the money that's owed to me and stay in business. But what if I then bend and twist that data to decide who's going to churn and I intervene? It's worth more to me. What if I then use it to set the price for a new product? It's worth even more to me. What if I use it to enter new markets? So you see, it's the same data, but we're getting more out of it. So we've got this unique asset class that's not consumable, but through the power of all of these exponential technologies reinforcing each other, we create more and more value. So I'm not an economist, but it's a very interesting prospect to have an asset that's only growing exponentially that creates value where none existed before. It's all very arbitrary at the moment. So what I'm going to talk to you about is the process by which you get value from data. Because when things are moving so quickly, it feels, how do you get onto this train? You know, it's only accelerating. How do we start this journey? Well, you start this journey with something that's never going to change. This is 14 years old. This is a variation. It's a simplification of something that's 14 years old called the Cross-Industry Standard Process for Data Mining, CRISP-DM. And what CRISP-DM does, and I've put this in place globally with several companies, is it gives you a framework, a process for getting value out of that data asset in a scalable and repeatable way. And the interesting thing is it starts with a business challenge. And this is the main mistake that businesses make when they're trying to get value from data, is they start with an analytical problem. But you're not an analytical business, or you might be. Generally, you're not. You make widgets, you serve customers, you do something in supply chains. You've got business challenges, not analytical challenges. So you've got to start with a business challenge. Only after you've encapsulated the business challenge do you look at your data. And it can be your internal data, it can be external data, it can be structured data, it can be unstructured data, it can be well-behaved data, it can be poorly behaved data, it can be messy, it can be clean. In fact, everyone's data is pretty messy. So, you know, my clients will often say, oh, I'd love to do what you're talking about, but our data's no good. And I'd say, well, you wouldn't be the first one. You know, there's one client that's come to me with perfect data before. So data is your asset. Then you apply analytics. And only finally do you do something with the result of the analytics. Now note that the left-hand side of this process has got nothing to do with data and analytics. It's traditional consulting. Do I understand my business? What's keeping me up at night? Where am I losing money? And the bottom bit is, and what can I do about it? So if you say I'm losing money because I'm losing customers to a competitor, I say, here's a magic wand. It will tell you exactly what customer's about to leave. It'll even tell you why. How are you going to bank the money? What are you going to do about it? Is it a marketing campaign? Is it an intervention? Are you allowed to do that? Is it legal? Is it ethical? Will the unions get in the way? So understanding the business problem and doing something with the insights is much harder than working with data assets, big data, small data, whatever, with analytical techniques. So we start and end in the business. We don't start and end with IT. We don't start and end with your data scientists. We start and end with your CFO, with your CMO, with your CEO, with your chief strategy officer. And you make sure that the insights I give you can be deployed. Otherwise, they're shelfware. I did years of shelfware. In the early days, people just wanted to see cool stuff with their data. Now they want to bank it. It's got to be actionable. So you've got to define what you're going to do with it up front. So the analytical technique is often put against a graph of complexity versus value. And we say the easy stuff is to describe what has been happening. Business intelligence, chop, slice and dice reporting. We then say we start getting more sophisticated and maybe we're talking about what's going on now. So we're segmenting or classifying. And these are the techniques we'd turn to answer a question about what is happening. So if your business problem is, I need to understand what is happening in this region with sales, we might say, let's do a segmentation based on sales. But if your business problem is, I just don't even know where I've sold more stuff, then we need to give you some descriptive analysis of sales. You might be wanting to be more sophisticated. I've got to predict how much I'm going to sell. I'm going to forecast what will happen, especially if I do something. That's prediction or possibly simulation. And right up the top end is something almost no businesses are doing very well, which is optimization or prescriptive analytics. What's the best thing to do given this forecast? Route optimization, I've done it for picking up garbage, we've done it for scheduling employees, we've done it basically for the allocation of scarce resources. But just because that's the most sophisticated doesn't mean that's the technique you need to apply. It depends on your business problem. If the challenge is optimize the pickup of my garbage to minimize fuel and tires and overtime, then sure, we'll apply an optimization technique. But if the business problem is tell me how much garbage I've picked up so that I can pay the fees correctly, then we'll use descriptive analytics. So you apply the right analytical technique based on the data that you need to answer the business problem in a way that's deployable. Now that deployment could be a report. It could be an automated system. It could be an Internet of Things type solution. So to make this tangible, I'm going to talk through a couple of examples. These are all things I've done over the years. And the first one comes from the area of, and they're big data examples. The first one comes from banking. And the challenge facing the bank was we need to have best share of market. We want to make decisions about our branches or other channels, digital, mobile lending, mobile devices, how many counters in that bank, how many financial planners should be there, in order to capture the best share of market. Now, traditionally, you take your data and you start to think about the branches and you draw a ring around them and you use something completely incorrect called retail gravity theory, which says someone's propensity to go to a branch is related to the inverse square of the distance between the branches, which is completely wrong. You should start with your customers because they're the ones you know the most about. And if you've got someone's credit card usage, transaction amount by merchant, by time, it's only 3 fields. But look how you can bend and twist it. Where are they on the weekend? Where are they in the morning? Do they spend more on food than that guy? Do they spend more on clothes than that girl? You can start to understand people's movement through time and space. And you don't say Matt Kuperholz is based in Camberwell because that's where I opened a branch when I was 8 years old. You say Matt does most of his work in the city and on the weekends he can be found here and this is how he spends his cash. And this is what he buys on the internet. So credit cards alone can be bent and twisted into a temporal, geospatial, price elasticity view of your customer. And then you look at every call into the call centre and every click on every website and every use of the mobile app and every complaint they've made and every cheque they've written and every mortgage payment they've made or missed and every product they've had and churned from. And the most I've modelled was 17,000 dimensions for 10 million customers. TD Bank. This is an Australian bank, different. But it was still about 4,000 or 5,000 metrics, which you can very easily get to when you consider every interaction of your customers. And then you get a very deep understanding of your customers. And only then do you look at the markets where you're drawing your customers from. And you project into them. And by understanding the customers you have and the markets you're drawing them from, you start to see where you're overweight and underweight in the type of customers you want. Because the key to this stuff is granularity. Not all customers are created equal, and you don't want every customer. You want some customers to go to your competitors. Capital One did this brilliantly in the States. You'd actually apply for a loan or some insurance, and they'd say, we can't help you, but we recommend this website here, and they'd shuffle you off to your competitor to make their book worse. Very clever. So only after we analysed customers and markets did we turn to branches and channels. Where's the branch? Where are the competitors? What's the fit out like? How many counters? How did the manager go? And with those hop, skip and a jump, customers into markets, into branches, we identified literally billions of dollars of funds uplift, but only because we considered all of that data and really made that asset work. Now, catching the bad guys is another great use for big data. And the reason is that the more data you consider, the harder it is to hide. That's me hiding behind the tree. Do you know how hard it is to make a fake Facebook profile? And I know because I've scraped the hell out of Facebook. I was able to predict whether or not you were going to claim on your car policy simply by looking at your Facebook page. What you said, what books you were into, who your mates were. We even picked kids automatically out of photos using skin tone analysis. It was pretty creepy, but it was 10 years ago, so you're allowed to be creepier back then. The point is that it's hard to make a legitimate Facebook... it's hard to make a illegitimate Facebook page look legitimate because of that whole history of all the posts you've responded to and all the comments you've made and all the things that you've interacted with. And it comes down to a really simple premise, which sometimes sounds so simple I can't believe I'm saying it, which is legitimate behaviour is legitimate because it looks legitimate, and illegitimate behaviour is illegitimate because it can't look legitimate because it's not. So if you look at enough things about transactions, and I've done this for banks, I've done this for governments, I've done this for gaming authorities. If you look at enough dimensions about transactions and let the machine self-organise, the stuff that's weird floats off to the side and you go, gee, that's weird. You go, yeah, that's David Walsh. He's got his own terminal and he makes a lot of money gambling. Okay. That's weird. I don't know why that's weird. Oh, that's weird because that's a meth lab and they're actually using the gaming authorities shuffle cash around, right? So when you compare the win ratio to the amount of cash moved and the distance between withdrawal terminal and accepted terminal, it just doesn't look legitimate. So finding and stopping the bad guys in whatever area, if you've got enough big data, it's very hard to hide. The challenge there is obviously find and stop the bad guys, and the science of social networking, which is bending and twisting the data to express the connectivity between individuals, is very relevant here. And in fact, some of the work we've done for universities considers social networks as well. We're trying to say what makes a good student experience. We've got all the tutorials people are in, we've got all their exam results, we've got whether or not they finish their degree. And it turns out there's this interesting sweet spot between putting people in a network that's too familiar and every lecture you've got the same old faces versus putting them in a network that's too diverse and you don't know anyone. And when you get that right and there's enough similarity but yet enough difference, people have a great experience, amongst other things. So a great use of data, not to find and stop the bad guys, but to find and encourage the right behaviours in your timetabling to get your students to stay at university. I've done a lot of work for the airlines, local airlines, overseas airlines, and the problem with the airlines initially was they weren't thinking granular enough. Platinum. But Granny's a platinum. She flies to London once a year in first class to see the grandkids. I'm a platinum because I've got to go to Sydney every week. We've got completely different needs, aims, wants, desires, but to call us both platinum and to think we're the same is silly. But if your challenge is to acquire, retain and optimise your customers, to get the most out of your customers, you've got to turn to your data assets. You've got to realise that, yeah, you're running antiquated systems because you can't turn those mainframes off because you're flying the plane every day. But you know when I booked. You know what I paid for my ticket compared to the person sitting next to me. You know when I turned up to the airport. You know if I checked a bag in. You know if I went to the lounge. You know if my plane left on time. You know who my stewardess was. You know if it was bumpy. You know how much fuel was left on the plane. You know if I arrived on time. You know if you lost, they don't lose your bag, they mishandle your bag. They know if they mishandled your bag. You know how I used my loyalty points. You know if I called the call centre. You know if I used the website. Yes, you have to stitch that together from 60 disparate systems. But when you do that, you start to understand your customers again in a granular way to allow, analytics provides for win-win. You can have a happier customer and a more profitable company. You see, because we're creating value from an asset without using it up, you can have a win-win, because normally my game, consulting, is zero-sum game. You're robbing from Peter to pay Paul. There's a winner, there's a loser. But in this case, by better understanding customers, Granny's happier flying to London and Matt's happier flying to Sydney because we're not both platinum anymore. You can flip it and you can say employees are like customers of an organisation. They are paying with their time and discretionary effort, and they're being rewarded with their experience and their salary. And then suddenly the challenges of acquisition and retention and putting the right person in the right place at the right time that you deal with for customers transposes to employees. But some of the stuff I've done with employees that I'm happiest about is actually getting them home safe, because everyone deserves to go home safe. And traditionally, safety was look at the claims, look at the incidents, look at the accidents, myopically looking backwards and try and figure out why people are getting killed. Yeah, hang on a minute. These people are operating on mining rigs. And that mining rig is collecting 100 data points every minute as the drill passes through the soil. And you've got the rosters, and you've got the weather, and you've got the training, and you've got whether this team's worked together before, and you've got whether the supervisor visited, and you've got when they started work because they checked in with their access card log. And when you join all of that data together, it turns out that you can genuinely find the leading indicators of when someone's going to have an accident or incident. And again, it's a win-win, because your claims don't go up, your premiums don't go up, and everyone gets to go home safe. I learned a lot about making ammonia a couple of years ago, which I had forgotten about from Year 10 chemistry. And when I helped this factory make more ammonia, this is an Internet of Things example, their challenge was, how do we produce reliably and efficiently and do our job better? And I said, what do you mean you're a factory? You make the same ammonia every day. They said, yeah, but we had a great week last week. We made a larger amount of ammonia, and it just didn't make any sense to me. And then I realised, okay, there's ambient temperatures and different qualities of feedstock. But it was more that the operators had this black art of steam reforming. Like, you serious? Why don't you use the data and figure out how it should be done? Well, what data? Well, you've got 5,000 sensors in your factory measuring pressure, temperature, and flow every second. What are you doing with it? When that gets too hot, we ring a red alarm bell on the control panel. So, well, have you still got the data? And they said, yeah, it's going to be difficult to get at. Anyway, so we got at the data and we put it all together and we looked at it as a series of complex multidimensional time series, and we were able to actually see what constituted a better way to operate the factory. And more importantly, we were able to see when something was going to break. Because to fix something preemptively, and this is about predictive asset maintenance, turns out to be much, much more efficient than waiting till it breaks and fixing it afterwards. And the final example, and one I think we're going to see a lot more of, because, and we've taken a big stake in this, there's a bloke called Russell Howcroft, a partner of mine and a great guy to work with from the Gruen transfer, who's joined us. Why has he joined us? Well, because traditionally we gave advice to CFO or CEO or Chief Strategy Officer. But the person who's becoming much more relevant at the boardroom table is a Chief Marketing Officer, because customers are changing. Customers are expecting to be treated as individuals. So your Chief Marketing Officer holds the budget of how to get at these individuals. And the challenge which you're facing now is, I want my 50 cents back. I'm not happy with 50 cents in every dollar being wasted. I want you to use my marketing dollars more efficiently. I want you to have the right marketing mix and the right message and the right medium, the right pricing, and I want you to be able to show me attribution where this marketing's working. And this case was fantastic. It was Pepsi in the States, and in those days, when you looked at red and blue of Democrats versus Republicans, it almost exactly looked like red and blue of Pepsi versus Coke. The rednecks down south drinking Coke, the hipsters up north drinking Pepsi. But when you look closer and got more granular, there were these little enclaves of Coke versus Pepsi. And the point was that if you took all of the data of the weather and the marathons and the childhood obesity and how much everything was being sold in every 7-Eleven, Costco and Savers, and every radio ad and billboard and TV ad, and we even had data as to how many times the brand was caught in the background of the Friday night basketball as the camera panned across the screen. And you put all of that together, you're able to actually see what was working, when and why, and what you can do about it. But only by munging all of that data, only by using artificial intelligence to make sense of it all. So these are some pretty high-powered examples. I can go on all day. I've done everything from, as I said, picking up garbage to growing tuna fish. And at 10 grand a fish, it's worth getting it right. But it all starts with identifying the business challenge, looking at the data you have to apply to it, deciding what the right analytical technique's going to be, and then doing something with it, deploying. So I've run a little bit over. We'll hold for questions later, but there is a funky slide that says questions and answers. And thanks.
Right. Thanks for having me tonight. I think my talk will be, we'll see how we go. So I'm going to talk a little bit about the fate of data science in Australia, and I'll explain a little bit about what I mean about this shortly. So the first slide, I swear Matt and I did not plan this at all, but this is eerily similar to one of his slides. Right? So the first thing that I'll talk about is how, I'm not sure why this is not quite aligned. Sorry. There we go. So the first thing I want to talk about is what do I believe data science is? To me, data science is basically the technology that is enabling the AI revolution that many people talk about now. Now, data science has obviously been around a long time. It has many names. Data analytics is probably the classic name for it. In the early days, unfortunately, the laser pointer doesn't work, so I won't point. In the early days, most of the data analytics problems that we solved were descriptive. And by that, I mean take data logs from a web server. My server crashed, so what do? I go look in the log and see what happened. Shortly after that, in the 90s, people moved up to the next stage, which would be diagnostics. So they said, we've got lots of data. We know servers are crashing, so maybe we can do something more interesting. We can go look and see if there are problems that are happening that aren't life-threatening, that aren't crashing everything. And the third level is sort of where we're at now, is what I would call prescriptive analytics. So in other words, what should happen? So for example, there are many classic examples of this for power management, power estimation. So companies, your phone company will estimate what they believe your power bill will be over the next quarter based on previous usage. These sorts of data analytics problems are quite easy. And now we're moving into sort of the fourth stage, sort of the next grand challenge is what are called prescriptive analytics, right? And prescriptive analytics are when we get to the point where we allow algorithms and machine learning to make decisions for us. For example, autonomous cars is a classic example of this, right? So we're within the next 10 years, most of us believe cars will be driving themselves, which means cars are making decisions for us, which is a bit of a scary thing, but that's sort of the grand vision of prescriptive analytics. So the next question is, that's what I believe data science and data analytics are. What is FATE? So FATE actually is an acronym and also something that Matt alluded to, which stands loosely for Responsible Data-Driven Analytics. And by this, I mean fairness, accountability, transparency, ethics, bias. There are many, many different words that get attached to this, and there are actually quite a lot of research on this problem. In 10 years ago, no one cared about this, right? If people would have gone to anyone who was doing data analytics, people would say, yeah, fairness, bias, it doesn't exist. In the last few years, however, exponentially is becoming more and more important. Some of the biggest conferences, interdisciplinary conferences in computer science, are based on the topic of FATE. And I have many friends and colleagues who work in companies like Microsoft who have whole fields of researchers that this is what they do full time now. So what I really want to talk about today is some of the work that I'm quite interested in, and many of the people in our group are interested in as well. And it's based on the premise of responsible by design analytics. I think this is a very important problem. In fact, I believe it's actually a grand challenge in research over the next 5 to 10 years. For many, many years, people believed that data analytics was unbiased. We have lots of data. We have algorithms that are making decisions. Surely, since it's not people, these algorithms must be objective. But the truth is, nothing can be further from the truth, right? The truth is that the algorithm is a direct reflection of the data that it's modeling. And unfortunately, the data that's being modeled often is biased in many, many interesting ways. And we'll see many examples of that. So I think that this is really, there's strong consensus in data analytics that this is one of the most important challenges we face in the next 5 to 10 years. Anyone who's working with data, including all of you. So bias. So I do machine learning, and it's very technical. In machine learning, there's this classic problem called the bias variance trade-off. But the type of bias I'm talking about here is human bias. I'm not talking about the kind of bias that we elucidate in algorithms. So what do I mean by bias? So it also turns out that a lot of my work is on search engines. Search engines actually are just complicated recommendation systems now. They have huge amounts of data, and a lot of the data they have is actually from humans. So it's important data. Unfortunately, this data is great at reflecting us and our best and worst, right? If you look at what happens in the US now, sort of the political divide, everything is polarized there, right? Either you're left wing or right wing. There's no one in the middle anymore. And those data biases are very strongly reflected in the news outlets and the news data that we see. So, for example, if you start typing Belgium into a search engine, it gives you some interesting query suggestions. One query suggestion is Belgium is in which country, which is an interesting result. And if you type something like the Dutch are, well, we've all heard a few jokes in our lives about the Dutch. They're great people, and unfortunately, the biases end up in the search engines themselves. Or even worse, if you type something like transgenders are, you will see really, really bad things. And it's because there's lots of data out there that's being mined and pushed into the search engines that says that this is what people want to see. So it's an important problem. And I hope that's not us. Not only is it an important problem, but it's complicated, and context matters. And by that I mean, So there are other great examples of bias existing in search. Image search is in the midst of a revolution right now. And in fact, it is the main motivator for all of the deep learning that's happening in the world today. Deep learning on images is actually what rekindled the interest in deep learning, because for years and years and years, image search was an impossibly hard task. And suddenly with deep learning, they were able to actually get really good results. Now, the unfortunate problem is that these models were built by a bunch of white men. And so all the images and data that they were using and trained on were white men. So if you looked at people of color or women, the predictors were really bad and hilariously bad sometimes. It would actually say that they're not even people. And there are other great examples of deep learning overtraining. For example, there's one called the elephant in the room. It's a classic adversarial example of deep learning where they train all these models of a person sitting in a room with desk and chair and sofa, and they just stuck an elephant in the back of the room. And suddenly the algorithm started predicting everything completely wrong, and no one could understand why. So bias is there. It leads to another interesting problem, which is fairness. Fairness in algorithmic injustice is actually an incredibly difficult problem. So this is another classic example that's been in the news lately. So there's this algorithm called Compass, which is a risk prediction algorithm in the US, in Florida. And the purpose of the algorithm was to decide if people should be released from prison on parole. Turns out that the algorithm suddenly started predicting white people should be released and black people should not. And so they tried to determine why that was true. And so they went to look at the data. And of course, it's not that surprising. There's a higher percentage of black people in US prisons, and there's a much higher chance that they will recommit crimes when they get out. So the algorithm was purely a reflection of the data that they had. Now, it gets more interesting than that. I say it's seriously hard because the truth is that some smart mathematicians went and looked at the way they computed the risk scores, and they found that the algorithm couldn't be fair because of the way it was formulated. So it's not actually possible to get both. And so this is quite an interesting example of why fairness is really hard and why it's an open problem and why people have to think about it. And you might say, I'm not in prison and none of my family members are. I don't really care. It turns out predictive parity does matter to all of us. The same issues exist in medicine, and medicine is actually one of the biggest fields right now for healthcare analytics. And this leads to my next discussion, which is on explainability. So again, part of the FATE framework. So interestingly in healthcare, I think that there's quite a lot of interest in using data mining, data analytics, machine learning to help solve hard problems. And there's lots and lots of data. There's almost infinite data now on watches and many IoT devices. And the problem is that many of the models we use aren't interpretable. So they can give us an answer, but it's impossible to understand why the model made the choice that it made. And this is also a deep and difficult research question, and it has far-reaching effects because by policy in many hospitals, you're allowed to ask for explanations of why certain decisions are made about your health, and you certainly don't want to be in the position where the system is making a prediction that you should have an operation when you clearly don't. So there's always that seed of doubt that you want to know the answers of why it's happening. And so there's a huge body of work out there, and people are interested in trying to understand how to manage explainability. And thankfully, deep learning, there is quite a lot of active work on this, and it is possible actually to explain models that come from deep learning. Now, of course, compliance is another one. Anyone here who's had to deal with GDPR would know that explainability is part of the game, and it's really unpleasant. So the other one that I'll say here is there's a long history of data mining where it's also very useful in that it finds patterns that humans couldn't possibly find. So a classic example is pneumonia patients with asthma have have a lower risk of dying. And that's very counterintuitive because they're both lung problems. And so without understanding what parts of the data, what features and information is giving you that answer, you can't actually go determine why this is true. So the classic example I remember when I was a student was beer and diapers. Has anyone ever heard the beer and diapers example? So it's a classic one, which is quite entertaining. Grocery stores discovered through data mining that if they put beer and diapers on the same aisle, people bought a lot more beer and diapers. It's really hard to explain why that's true, but they didn't care. They made a lot of money doing it. So these sorts of things exist. So explainability has many interesting features. And it's also important to point out that explainability is not justification. And understanding this distinction is actually quite important, particularly if we start thinking about prescriptive analytics. So prescriptive analytics is when we're letting machines make decisions for us. If you recall, that's sort of one of the holy grails of AI. And when you get to that point, you don't want just explanations, you want justifications for the decisions that are made. And this requires people. And it's very difficult to understand how to do it without people. The other one is there is also a very hot research area on causal learning. So causal learning and causal inference is been around for a long time, particularly in health. It's an incredibly important problem. I went to an amazing tutorial on this problem at KDD about 4 months ago in London. It's a really interesting problem, and it's a really interesting idea, and there are really clever ways to build structured inferential models as part of learning that can be used for many things, particularly in healthcare. So the classic example that they gave in this tutorial was the effect of exercise on cholesterol. So this is another one of those correlation is not causation issues. If you look at a large population of people, you will find that there is a correlation between people who exercise a lot and people who have high cholesterol. And if you look at the data, the more the people exercise, the higher their cholesterol is, and it makes no sense. But it's because of the way we're looking at the data. The most important part of the data actually is the age of the participants. Turns out that people, as they get older, are more likely to have health problems, are more likely to exercise and take care of themselves, and more likely to have high cholesterol. And that's actually what the causative agent is here. And there are ways to actually find these sorts of things out in the data. So it's an interesting problem as well. So the last one that I want to talk about is ethics. So in teaching, the classic ethical dilemma is called the trolley car dilemma. How many people have ever seen the trolley car dilemma? Raise your hand. So great, we have a few. It's a pretty standard textbook thing to think about, and it has direct implications in things such as autonomous vehicles, right? It's used quite often in courses where we think about these problems. So the trolley car dilemma, it says the trolley's brakes have failed. You're in control of the switch. If you activate the switch, one person dies. If you don't activate it, 5 people die. So what do you do? How many of you would throw the switch? Raise your hand.
Is there a third option?
Well, we haven't got there. How many people would not throw the switch? Raise your hand. How many people would do something else? Okay, what would you do?
I don't know. Put something else in front of the tram. What's the third option? Is the definition that there are only 2 options?
There are several possibilities, but yes, the way it's the general formulation is you can't throw yourself in front of it.
Oh, no. I'm more important
Yeah?
than 10 other people.
Activate the switch, set the 1%.
Yes, but what if the one person's too far away? So if you throw the switch, that's called utilitarianism, right? You know, the need of the many outweighs the need of the few. And of course, there are people that have moral, ethical, and religious dilemmas in this, right? If they throw the switch, then they have caused someone to die. If they do nothing, perhaps they haven't. And again, that turns out is what the car probably should do will make people very unhappy. And that is the car should flip a coin and make a decision randomly. And the reason that's true is because the car will never have all the data it needs to make the right decision, just like you think you might, but you don't. What if, for example, the one person is a 5-year-old child and the 5 people are all terminally ill and they're going to die in 3 weeks? So what's the value of life? So there are many ways you can look at this and say it's never black and white, even when you think it is black and white. So decisions like this are very difficult. So ethical dilemmas are interesting, and there are lots of problems related to this. So to summarize, I think to me, and an area of interest to me, and clearly to Matt as well, based on his discussions, is what I call responsible by design data science. I think that if you are running a company or a government organization right now and you don't have a policy to deal with this, you should get one immediately, because it is a big deal. And if you don't start thinking about it, it's going to bite you really, really soon. I also think that as we move forward, we all become more dependent on machine learning, and the problems that exist here will only get greater. We have more data, we have more tools, but they're always going to be biased, and there are always going to be these problems. The good news is that, like I said, I think this is a really active and fantastically interesting area of research. There are a lot of smart people working on it. There's a lot of important advances being made now that people recognize the problem and are willing to try and solve it. And I think that we can all benefit from that. So the final thing I'll say, turns out, again, so the Research Center at RMIT is going to launch a week from Wednesday. So we have a research center here called the Center for Information Discovery and Data Analytics. I'm the director. There are currently 22 members at RMIT across engineering, science, and business. And I suspect more people will join. We do a lot of things. If I were to give a one-sentence pitch, I believe that what we do is human-driven data analytics. We're interested in the human element of data and systems. And if you want to come to the launch, it's a week from Wednesday. There's an Eventbrite link at the bottom. Please feel free to register and come. If you don't want to come or you can't come, there's a link to the center, and I'm happy to answer any questions. Sorry. Hello?
Okay, so really interesting presentations, fantastic. In fact, I was seeing things that there was a lot of symmetry between both presentations, the ethics behind big data, and also the where it's going and what's happening with big data. And as both speakers were talking, one of the things that came to my mind was something that's was pretty spooky with Facebook, Matt, was Cambridge Analytics, which was a big data company that was using people's data in order to predict political voting behavior, and how ethical is that shape? And then the other side of that coin, when I was thinking, was many political parties now are using big data in order to predict outcomes. So we're polling people before elections, for example, to make a decision around who's going to be elected or not elected. And what's kind of interesting is we've got things that are really weird happening, like Brexit was not predicted. We've got things like the Trump election, which was not predicted. So yeah, big data, big ethical problems. Let me start by asking you, Matt. Is big data coming up against a wall in terms of its ability to truly predict where things are going?
No, I think based on my experience anyway, it's only going to those exponential technologies, not just the data, but our ability to make sense of it and do things with it, and work with fragments of information and work with information that we know is badly collected or noisy. I mean, I've seen a couple of techniques that actually did get Brexit and did get Trump, but they weren't based on treating all data equally. They were based on finding experts within the data and using the right incentives and gamification to allow those experts to compete in a way that they were spending limited credits, and they nailed both of those predictions. So no, I think we're actually only going in one direction with regard to predictability. Not sure whether that's right or wrong. Again, that's back to my opening remarks about abundance. I think we're headed for times of abundance. Dataism is a really interesting concept as well, from Amadeus and other pieces of literature.
So Shane, how ethical is Cambridge Analytics, those kinds of incidents?
Oh, I think it's clear it's unethical. It's as unethical as whether or not Russia influenced the U.S. election is another classic example. From Facebook's perspective, they made a lot of money off those ads, so they don't really care, right? So because there are no laws in place, so it's an interesting question: is did they do anything wrong? I think that's a tough question. I do agree also with what Matt said. I think every company, probably many of the people in this room, are getting really good at collecting contextual data on people. And having that data is a game changer. It's why companies like Google and Facebook are so far ahead of others, because they have so much data, contextual data. And as other people catch up, they're going to be in that. Now, I think, again, it's more than an ethical dilemma. It's a fairness dilemma. That's about being objective and being unbiased as well. So, yes, I think what Cambridge did was wrong morally, but it wasn't illegal. And so you have to decide how capitalist you are, I guess. I don't know. How willing are you to make a dollar? And so I don't know.
Excellent. Can we take some questions from the audience? We've got microphones going around, so could you just introduce yourself and the question, and if you're directing it to one of the speakers. Yes. Yeah, here you go. You take this one.
Hello. I understand that time's limited, but I only heard one oblique reference to personal data protection, and that was sort of a dig at GDPR. But don't you think that in the same way that risk is part of the flip side of value, personal data protection is going to become the flip side of the data analytics, and that to improve what we do with one, we're going to have to improve what we do with the other?
So Tim Berners-Lee, one of the original creators of the internet, just left his post at CERN, and he's starting a new company, and the company's goal is to enable people to own their own data. I think it's an interesting idea, and it'll be interesting to see how it plays out. I think obviously big companies that make billions of dollars, you're the customer. I mean, your data is the product, right, as they say, because you're getting a free service. So it is obviously a part of fate. Absolutely, is privacy. That's the star in there. Absolutely, privacy is very important, and people care a lot about it. I think people over 35 care a lot more about it than people under 35. That's my personal opinion, and I think there's a lot of evidence that show that young people just don't care. And maybe it's because they haven't learned, they don't have enough not to care, or maybe it's because the...
Access requests are already coming from people of all ages. Under GDPR, subject access requests, the ones I've seen, which is only a small sample, they're not, don't seem to be age right. It doesn't seem to have a bias.
That's fair enough about GDPR, but I think generally people care more about, I don't know, my personal perspective has been that younger people are more willing to give their data to get free things, I guess is the bottom line. They're less concerned about the implications of that, and maybe that's just naivety. I'm not sure.
I'm not sure it's naivety. I think that remember when Gmail first came out and we got targeted ads, and there was this uproar of how dare the computers read my email and give me a targeted ad. Do we think twice about that now? Or your search history in Google? I mean, have you bothered to find the browser that will give you full anonymity? Because that technology is out there. And if enough people want it, there will be an operating system that will guarantee your anonymity. And you can use Tor and you can use encryption.
By the US government.
There are equivalents, and people will vote with their vote with their feet and their hearts and their minds. And I think I agree that it's something that, and I'm a massive privacy advocate actually. But the governments, I don't believe, and these are not the official views of PwC, I just don't think they're going to get there fast enough. I don't think they've got the right talent. I think GDPR is incredibly heavy-handed and not the right way to go about it. I think technologies like distributed ledger and some of the thinking that's been done by Don Tascott about this technology being a way for you to carry your digital identity and profit from it. And Jaron Lanier with Who Owns the Future, this idea that we should all be recompensed through giving access to our data away, that might be the future that we're going to be dragged towards, but only when consumers care enough to make it happen. Yeah?
Another question?
Yeah, thanks. Great. Can you hear me? Yep. So you touched on AlphaGo. And AlphaGo is moving more into the emotive prediction, or the game of Go. Two things. One is the law. You mentioned, I think it was Cambridge Analytica, but it wasn't illegal at the time. But if we've got predictive analytics, why do we need to wait for the regulation to catch up to the data? And is it not incumbent on the digitists to predict regulation or create their own ethics or boundaries?
I think that's where Shane was coming from with responsible by design. And I think that's where the business I'm trying to build around, let's talk about Dr. Finkel's trying to encourage this idea of a Turing mark, that the consumer will say, I will take my preference there because they are to a standard responsible with their use of data. I do believe in the power of the market sufficiently informed if they care enough to make these decisions.
Yeah, I agree. I think we have a responsibility. Of course, there will always be people who are willing to cut corners to get there first or to make money. And if you buy their product, then you're supporting that. Right, so I guess you have to vote with your dollar.
Facebook is not a right. You don't have to use it. There's a slam poet called Max Stozel who writes fantastic poetry around the responsible use of data. Really, really good. I even made my kids go and have a look.
Other questions?
Thank you. Hi, my name's Hester, and this one's for Matt. I really enjoyed seeing the process clearly on the screen that you use at PwC. How would you recommend that entrepreneurs or small businesses that can't afford a data scientist could learn that quickly? Which tools would you recommend beginning with?
Well, I think what an amazing time with the dissemination of information and the ability to do massive amounts of online learning essentially for free and then have access to incredible open source tools to practice with. Really, what an amazing, amazing time. So you can start anywhere. There's fantastic beginners courses for data mining. We talked about KDD, the knowledge discovery. There's some guys I followed or was involved with in startup to their sale to Google, Kaggle, gamify data mining, and you can put it up there for people to compete with. There's really all kinds of tools and semi-religious wars about Python versus R, and you can really start anywhere. I think just, free beginner data mining, but start with the problem. Make sure you know the problem you're trying to solve and what you're trying to do with the results. Educational institutions provide a fantastic opportunity, and many students would be happy to try something out. You can put stuff out onto Freelancer and other sort of job posting sites and get some great data mining done very, very quickly, very, very cheaply.
I absolutely agree 100%. I think in computer science, we have capstone projects. I'm sure they do in the business school as well. If you give a well-designed project, say, this is the data, this is the information I want, you can find someone who's keen to give you the information. And it doesn't cost anything. So,
and that process in particular, CRISP-DM, CRISP-DM, was IBM and SPSS 16 years ago, and that's all in the public domain. You can download that and go ahead and use it as a process. Yeah, for sure.
Oh, thank you. Hi, my name is Wendy. This is just touching on the same issue regarding GDPR, in fact. If you hire someone through a freelancing site, how do you know that your GDPR policy is still legal?
Yeah, I think small companies are in a world of hurt for GDPR, so I think I'm not qualified. Definitely, there might be people who can give you better advice on that one, Matt.
I know that if large companies all around the world were taking GDPR to the letter of the law or making the effort to interpret it, our GDPR consulting arm would be run off its feet, and it's not. So I think it's a very blunt instrument. I think it hasn't been tested. I think at the moment you're better just to be making your best efforts. It's certainly nowhere near as scary to business operators as Y2K was 18, 19 years ago. Because this idea of I have the right to an explanation for how you made a decision that affected me, no one can give you that really at the moment.
I was thinking more about having a freelancer, for example, having access to all the data, the private data that people...
Yeah, but I think you might have bigger issues with that situation than GDPR.
Yeah, I think in that case, then now you're in the world of contract law, right? You need to make sure that they've signed the right contracts and they're taking responsibility for the privacy of that data. And if they don't, then they're liable.
Or even better, obfuscate the data, put in other identifiers, add some salt, add some noise. There are many ways that you can take responsibility for the data before you release it to a freelance contractor.
Okay, I think we have time for one more question before we have food and drinks. Is there another question? Yes, just here.
Have you come across any instances where organisations are trying to put a dollar value on their data and put it on their balance sheet? Is it coming?
Yes, it's a really interesting one, isn't it? What would Google be worth tomorrow if they had nothing on any of their hard drives anywhere? It depends what it's very, very complicated, because how do you put a value to something where a new analytical technique could come out tomorrow that suddenly provides for insight in that data that didn't exist yesterday? So it's definitely hard to put on the balance sheet. I mean, we provide services all the time in mergers and acquisitions around the quality and completeness of the data. Yeah.
It's usually per person, right? So usually there's an estimate of the value of the data per person. And there are ways to do that. It's an estimate, right? I don't know that it's how reliable it is, but certainly it seems to be reasonably reliable, particularly in M&A situations.
And I think this is the really exciting things. You know, the robots are taking our jobs. 90% of people are going to be unemployed. Well, hang on a minute. AI ethicist didn't exist as a profession a couple of years ago. Accounting standards of audit were invented in the 1930s to protect investors from, shysters. And so we got these audit standards for listed companies. There are going to emerge standards for responsible and trusted AI. There are going to emerge standards for valuing data and for protecting individual rights. The world will head in this direction. Everything's just so new at the moment, the jobs haven't caught up yet. And also regulation, and also enforcement, and also testing, and also evidence. It's exciting. The pace of change will never be as slow as it is today.
It's a great time to be alive. Why would you want to slow it down?
It's a great time to be alive.
There's lots of great problems to solve.
Okay, can everybody join me in thanking both Matt?
Cheers, man.